All right, it's my pleasure to introduce Dale Dunlop, Director of HPC and Cloud Technology at Altair, and he's going to talk about Altair's cloud vision. So, Dale.
Thanks, Bill. So, thank you everyone for hanging in here. If you are looking for the real technical stuff, that's Chris in the other room. So, what I'm going to be talking about here is Altair's cloud vision. This is more of a high-level discussion about our cloud strategy and what we're doing with clouds. Yesterday, if you heard Jim Scappa's presentation, you heard a little bit more about Altair, who we are. This is the PBS users group meeting, obviously, but Altair is a much larger company. And I won't go through all the different companies that we have, but the point is Altair is a big company. We do a lot of different things. But the thing that's important here in this context, PBS is key to all these businesses. Our Hyperworks business writes apps that use PBS Professional. Altair Product Design is a heavy user of PBS Professional, and so on. So PBS is a key part of our business, all our businesses, and that's what I want to leave you with there. We have a lot of customers in a lot of different industries. You've heard a lot in the presentations that Altair makes. You see a lot of stuff about mechanical design. That's where our roots are, but we also work in a lot of different industries, not just automotive, where we started, but aerospace, lots of different businesses, government. There's a lot of different industries represented here. And again, the key point is PBS Professional is part of that, and we have a lot of experience in a lot of different areas. I want to talk about Altair's focus. Again, the larger Altair focus is on simulation, predictive analytics, optimization. You can read all that stuff up on there. In a nutshell, what we do as a company is try to figure out how to do stuff better, okay? That's from the early days of Altair. The company first started as a group of engineers trying to figure out how to do engineering using tools in unique ways. There are a lot of engineering companies out there. The reason Altair has survived and thrived is because the whole focus of the company is around doing innovative things, and that includes, you see that in a lot of our products, a lot of our services, and it's important when you talk about cloud because as you see here on the focus, high performance computing and cloud is a part of how we provide the benefits to our customers. You saw this slide yesterday. This is one of our key messages. Altair as a company, we're the only company that I'm aware of that make HPC tools like PBS Works. We make HPC applications like the Hyperworks family, and we also use them. So when you talk to our engineers, they understand how to run PBS because they're doing that in-house. And we have a lot of computer systems in-house. We don't have, a 16,000 core machine like lots of you do, but we have machines with several hundred cores, and we're always buying more. We have a good-sized data center, and we're working on filling it up. So we know HPC apps, but we also know cloud, because these tools that we use for HPC are also cloud tools. PBS is a cloud building tool. Hyperworks are cloud-enabled apps, and we use cloud for high-performance computing in Altair Product Design. I've talked about cloud already. one of the things I've learned when I talk to people about cloud, first thing you got to agree on, what is cloud? Everybody's got their own idea. There's multiple definitions. It makes it very confusing. So I put up this cheesy graphic here to sort of drive home the point. When you talk about cloud, you don't get a good answer, right? And it really is a hazy kind of definition that you'll see. Our definition that you saw, Bill's presentation yesterday talked about access to one big computer. That's it. Real simple. And by that definition, most of you are actually using cloud, whether you call it cloud or not, whether you call it just a cluster. In our definition, it's a cloud. I put up the NIST definition of cloud here in this little chart to just sort of show visually what the cloud characteristics are. And even this definition could be a little ambiguous. I won't go through this whole thing, but take, for example, resource pooling, multi-tenancy. A lot of people take that to mean, like in, say, Amazon EC2, the multi-tenancy comes into play when different customers get different instances. But in a PBS cluster, a PBS complex, you could handle multi-tenancy through different queues. It's a different way of looking at it. You can argue whether it's a cloud or a cluster or a grid or all that other stuff. It doesn't matter really for our definition. We consider that all cloud. Another example, rapid elasticity. Again, a lot of people will use that to say, oh, you have to have visualization, or not virtualization in order to have a true cloud. Well, I don't see virtualization on here at all. It's not on the slide. It's not in this definition. You could argue, it's a reasonable argument to say that rapid elasticity implies virtualization technology. But from our perspective, you can also have rapid elasticity if, as in PBS, you have provisioning hooks that allow you to rapidly provision additional nodes to run your jobs. Where some of the haziness comes in there is using words like rapid. What does rapid mean? In certain industries, like we have jobs, finite element jobs that run on 128 cores for 2 weeks. In that context, rapid is 10 minutes. If it takes you 10 minutes to provision those nodes that are run for 2 weeks, that's pretty fast. If your job takes 20 seconds on one core, rapid is not 10 minutes. It's more like milliseconds. So again, if you look at the context of where we're coming from, our background in high performance computing, we see cloud a little differently. The additional things that I added into this definition, we consider, we work a lot with HPC clouds. And I would argue that you'd add to the NIST definition, you need to maximize hardware performance, allow for multi-node parallel jobs, and also be able to handle big data in order to have a true HPC cloud. And so that's sort of our focus on cloud. I'll step back a little bit here and remember why we're talking about cloud computing, because I'm not interested in cloud just because it's cool and it's new. Again, Altair focuses on doing things differently, doing things better. And I found this ancient example from one of our engineering groups. This happens to be a airplane door hinge. And in the old days, way long time ago, it would take 3 months to design this thing, and you'd get a certain mass out of it. Using modern tools, some of our Hyperworks tools, you can cut out a lot of the masses, a significant mass reduction, but also very important, the design time went from months to weeks. And as I say, this is an old example. I think we're even better than that now. But the point of this is the idea of cloud is to give access to users to use this type of tool. So there's unique tools out there. People are developing them all the time. The Hyperworks tools are very unique. But there's barriers to entry, because if you want to run some of our codes, you may need to figure out what kind of hardware do you want to buy, what operating system do you want to run, what interconnect do you want to use, what size disks, how much memory, all that kind of stuff. Then you got to get it installed. You got to have application licenses, all these kinds of things. And cloud just enables access to this. Again, access to one big computer. It enables you to have access to more resources in an easier to use way, gives you faster turnaround and better return on investment. So here's some of the common acronyms you hear in the cloud world: infrastructure as a service, platform as a service, software as a service. If you've got any familiarity with cloud, you've heard those before. Wanted to sort of drill down and look at where Altair plays in these. In terms of infrastructure as a service, we have hardware partners that build the infrastructure. Platform as a service is really where we play in terms of scheduling, security, licensing, remote visualization, all these kinds of things. And then software as a service is the endpoint. That's what we want to deliver to customers. And so the key thing is PBS Works is for building a platform as a service, and Hyperworks Enterprise is for offering software as a service. More details about Hyperworks Enterprise. Again, PBS Professional is a foundational layer for this. On top of PBS Professional, you could say cloud enable Hyperworks, our software, especially through Compute Manager, which is our web portal, and you'll be hearing more about that in the next couple of presentations. Implementation models, again, clouds, there's different ways, different types of clouds, different type of service models, but how it's deployed at a customer site, there are private clouds. And I would argue that most of you, if you have a cluster running PBS Professional with some sort of interface on there, even if it's, especially if it's a web interface, you probably have what I would call a private cloud. A public cloud, the most obvious example is Amazon EC2. We've created our own public cloud called Hyperworks On Demand, which provides software as a service access for our Hyperworks products, especially AccuSolve, our CFD solver, Radios, our crash solver, OptiStruct, which is optimization tool, structural optimization. And then using PBS Professional, we can tie those together and create a private cloud. And the point here is that we see this as the vision, and so we are working through the PBS development team, Hyperworks development team, to identify the best way to do this and to make sure that our products support this type of model. So you see in PBS already, you see mechanisms in place like peer scheduling is a key technology for this, provisioning hooks, those kinds of things, and you'll see in the future an emphasis on additional tools that make this kind of a hybrid cloud achievable within your company. I wanted to talk a little bit more about PBS application services because I didn't see it on the agenda. It's sort of a foundational layer to Compute Manager. And I'm feeling a little bit guilty about not being very technical in this presentation at all. So a little bit more technical slide here on PBS application services. And this just illustrates an enabling technology that we have in place that allows building of clouds. So you have PBS Professional on the hardware, and then PBS Application Services provides a web services layer using standards, portable definitions, things like that, that you can expose PBS in a different way. So from the command line, everybody knows Q-sub, you just submit your jobs. Using PBS Application Services, you can create a repeatable application definition that says, for my job, for example, Radios, AccuSolve, these are the user inputs you need to collect, and when you collect that information, this is how you run the job. Think of it as a web-enabled or web services-enabled run script. And by creating this web services layer, we're able to expose this through Compute Manager. And again, you'll hear more about that later, and you'll see what the user interface looks like. But while you're seeing that, just remember that that is a consumer of these web services. Okay? And I'm real conscious of time today, so I've got a couple minutes left. And I wanted to allow time for questions, but I also wanted to try and keep on time. So, are there any questions?
I haven't heard anything yet talk about economic considerations in terms of amortization models or per compute instance models on how you'd actually imply or reuse legacy HPC in a cloud environment, whether it's worth doing it in the first place.
Okay, so the question, I don't know if everybody heard that, is about economic models, whether it's worth it to do HPC in the cloud. Interesting question. It depends. I get grief from people all the time because I tend to give real measured answers. So sorry about that, but it really depends on your situation. When you look at the economics of running in the cloud, you got to figure out what is driving the cost. Is it the cost of the hardware? Is it the sysadmin cost? Is it the power cost? A lot of our customers in the commercial side, the thing that drives the cost is the application license itself. So if you can run in the cloud and you figure out that the hardware in the cloud is cheaper than the hardware in-house, but you still have astronomical license fees, it's not that much of a benefit. The other thing is security sort of skews the equation. If all your intellectual property, if you put a certain value on that and you cannot afford to have any security issues whatsoever, then it changes the cost model of it going in the cloud because there's the risk associated with the public cloud, right? So I'm sorry I can't give you a better answer, but there's a lot of concerns or a lot of considerations in that. You have another question?
I'd like to ask your opinion on something I hear from usually my management who are saying, oh, we must use cloud, we have to have a cloud. And what I really think is that they would much rather have the use of portals rather than the cloud. And the technology behind that portal is kind of irrelevant. Is that something you see in the industry?
Yeah. So the question is, you know, you get management pressure to implement a cloud, and I see that all the time. And I used to see that with grids. Oh, we have to have a grid, right? Because somebody hears it on NPR, or they see it on, you know, they see the IBM ad, right? Oh, to the cloud, right? Oh, I got to get me one of those, you know. And we're behind if we don't have one of those. And to me, the argument is, the way to address that is, yes, we have a cloud. It's a private cloud, and here it is. And if there's a real backlash to that, yes, we have a portal. So this proves that it's a private cloud. And I think Compute Manager is one way to address that. A lot of people have written their own web interfaces. You know, with Compute Manager, we now have a good one in the PBS Works family. But I don't buy the idea of we need a cloud just because everybody else has one. I think there needs to be some real business value there. And that's what we're focused on.
All right, one more.
Okay, one more.
Yeah, about your hybrid model, hybrid cloud model, what's your vision about the data preparation using public cloud? Because lots of the CAE jobs, you need data first to use the computing power.
Right. So when you talk about CAE applications, data transfer is a huge issue. Like Hyperworks on Demand, input files are typically on the order of tens of megabytes, and output files are on the order of hundreds of gigabytes. And it's, for a lot of simulations, it's really not practical unless you have a really good internet connection to transfer, you know, 500 gigabytes of output. So to me, that gives us two opportunities. One, I think more people are going to embrace private clouds in the short term, because if you have your cloud on your local area network, file transfer is much simpler. The other thing is, and we are investing in remote visualization technology through our Display Manager product, which will enable you to run our applications in the cloud from the very beginning, so the data never gets transferred. So imagine if you're doing a finite element analysis, you do your modeling in the cloud, the data all sits there, you run the analysis there, you generate your output, your post-processing all through the cloud, and at the end of the cloud, or the end of your project, you just click a button and say, archive this, and then we ship you, you know, a couple terabytes of data on disk for archive purposes, right?
Okay. Thank you very much.
Okay, thank you.